Hello, everyone. Welcome to one of the last sessions of the conference. Congratulations, you made it. My name is Denis Magda. I've been working with distributed systems, applications, and databases for the last, I think, 8-9 years. And today, I'd like to share my experience on how to run Kubernetes cluster on a distributed database, in particular on a distributed PostgreSQL. As you can see, I don't have any slides. It's not because I'm lazy to put them together, but generally my goal is to show you how everything works in action. It's going to be a hands-on session for me. And then if you find this session useful, then you will be able to Google or go to ChatGPT, and you will be able to learn from resources prepared by people who are much smarter than me in this area, all right? So that's the reason. So let's take a look at the plan. First, we need to figure out what is etcd. Then we will talk the reasons why we even have this session and why some of the folks within the Kubernetes community decided that we need to have some replacement and alternate option for this distributed storage. Then you'll see we'll talk about the project Kine, because Kine is a special component that makes it possible to use Postgres, MySQL, Oracle, or pretty much, I think, a bunch of other relational databases instead of etcd for Kubernetes deployments. And then I will show you real-world examples. So speaking about the demos, what exactly we are going to do? We are going to run Kubernetes on vanilla Postgres. And vanilla, I mean it's Postgres, open source, single node cluster, single node instance. And after that, once we make this happen, we will do the same Kubernetes, but on distributed Postgres. Okay? That's the plan. By the way, question, how many of you came to this session because of Postgres in the title? Anyone? Cool. I knew that. All right, so what's etcd? etcd is a distributed, scalable, and highly available key-value store or key-value database. It's quite simple, but the power is in the simplicity. Because what it does really well, it works across several nodes, across several machines or VMs that you have in your cluster. It uses the Raft consensus protocol to replicate all of the changes. And then if any of the etcd nodes goes down, then guess what? Their database itself remains available. The data is stored in a consistent state. And that was one of the reasons why Kubernetes selected etcd as a component. So let's write this down. etcd is a distributed and a highly available data store. It's just, you can think about it as key-value database. And Kubernetes, how is it related to Kubernetes? Kubernetes uses it as a meta store. So all the configuration, all the system information about your Kubernetes cluster is stored in etcd. Things like how many nodes I have, how many services or pods, what's the current configuration, what's a state of this particular service. All this information is stored in etcd. And it also has to be consistent. There should be no any inconsistencies. So this is how it works in practice. And why etcd is not enough? Generally speaking, etcd works for the majority of the use cases. Otherwise, there would be another default option for Kubernetes deployments. But still, there are some of the scenarios when etcd is not enough. Even though etcd is scalable and distributed, it has some scalability limitations. For instance, there might be scalability issues for large Kubernetes deployments. And we are talking about, let's say, hundreds or thousands of nodes. And I personally was involved in one of these projects when we had hundreds and hundreds of Kubernetes nodes, and we had to replace etcd with another distributed database. It was not Postgres, but it was distributed because we had to tackle a really huge load. Another reason, what I see is that the state of the etcd community So generally speaking, some of the people on the internet, they raise a concern that yes, etcd is a cool project, it does what it was designed for, but there are a few maintainers, and those maintainers work for the companies who are not interested in supporting etcd. So generally speaking, sometimes it takes a while to incorporate some change and to move the project forward. So like the community is not thriving, the community is basically at its current state. There are a few people who know how to build and move it forward, but it's not growing. And some of the people who belong to the Kubernetes community, they're saying, hey guys, Kubernetes community is thriving, right? It's growing, but there is one of the components within our ecosystem and we depend on it. And in that component, we don't have just a fresh kind of number of new maintainers who are coming, who are getting the knowledge and keep growing the etcd. As a result, and there might be some other reasons why people might want to select an alternative solution for the Kubernetes metastore. And when we are going to the PostgreSQL and distributed PostgreSQL, there is a project within the Kubernetes community called Kine. And what's Kine? Kine is a layer between Kubernetes cluster and a relational database that lets us to replace etcd with databases such as SQLite, Postgres, or MySQL. So generally, that's a website. Yeah, it belongs. It's here, and it acts as a shim layer. So let's say that Kubernetes still, like the way it works. When we use Kubernetes, Kubernetes has this API server, and the API server directly interacts with the etcd. And generally speaking, if we want to replace etcd with Postgres, then API server doesn't do this directly. API server still will be executing etcd, making etcd-like calls. And what Kine takes, Kine is used, like supports, implements the etcd APIs. It will be receiving all those calls from the API server of Kubernetes, and then it will be translating those API calls into SQL requests that will be executed over Postgres or another relational database. So the story is very simple. Today for the demo, I will be using K3s. How many of you use K3s? Anyone? All right, full crowd. And for me, like for the demo, it's a perfect solution because I don't need anything. I just use my laptop, one of my VMs in the cloud, and we are going to start it. So Kine, you can find it in the architecture. So this is how it looks like. You have your processes, they interact with the API server, and the API server talks to Kine. And if you want Kine to use Postgres or MySQL, then it's easy to support. So this is what we are going to do. Now, going back to our plan, that's Kine. That's all you need to know. Basically, etcd is used by Kubernetes as a metastore. All the cluster information, cluster configuration is stored and maintained in that storage. And there are some of the reasons, including these two that are listed, not on the slide, on this document, that might provoke you to consider an alternate storage implementation for your Kubernetes deployments. Now, let's start using Kine with K3s for our demo. And then if you want to use for vanilla Kubernetes deployments, then you also will be able to use this solution. So my infrastructure for today looks as follows. I'm going to use Google Cloud, and I'm going to use 3 virtual machines running across several regions. We have virtual machine in US West 1. It should be in Oregon. This one, US West 2, it should be, I guess, in Las Vegas. And this one, West 3, is in Salt Lake City. The reason why I have these 3 VMs, because in the end, we are going to deploy a distributed instance of Postgres. It's called YugabyteDB. I will talk about YugabyteDB later. But I want to show you how distributed PostgreSQL cannot, just support what's already supported by etcd, but also go beyond those capabilities. And one of that capabilities is that it can run and efficiently execute across a multi-region and multi-AZ cluster. With this configuration, our Kubernetes deployments will be able to tolerate and scale not just across several servers or several zones, but also across several cloud regions or private data centers. Okay, so let's start with this machine, because this is where I'm going to deploy my K3s instance. Closing the slides. Let's SSH. Yeah, this should be this machine. Okay, so let's start with Postgres. I have Postgres running. This is a Ubuntu machine, and Postgres is pre-installed. Let's just do the simplest solution. We will use my local instance of the database. If we check the state of the database, we don't have any relations. We don't have any tables yet. And this is what we are going to fix shortly. Let's open one more pane. Let's split it horizontally. And I want to do it this way. I will open one more connection to the same virtual machine. So you can see that the VM is the same. It's here. And right now, let's start K3s. Let's start our Kubernetes cluster on the same machine and connect to Postgres directly, replacing etcd. How does it look? So generally, we are going to use this script. We are just using curl. We are downloading the latest version of K3s from this address. And then we are going to start this script. When we start, yes, we create some sample token. This is necessary. And what's most interesting for us is this parameter that we pass to the script, data store endpoint. This parameter is going to be passed to Kine by the Kubernetes. And here, in the beginning of the URL, we say Postgres. So this is indication to Kine that you need to use your implementation for Postgres. Not for MySQL, not for SQLite, but for Postgres. And after that, you have the connectivity settings for your database. So this is the username Postgres, the password Postgres, and this is the address, local host on this port number, and the database is Postgres. Let's start it. So the script has been downloaded, and we start, and this K3s cluster is being bootstrapped. What we can do right now, we are connected to our Postgres database. You can see that basically when it starts, there is just one table that is created by Kine. And inside of this table, all this information about the cluster configuration and the state of the cluster of Kubernetes is going to be stored. Let me show you what happens right now. If we try to calculate the number of events, of records in this table, so right now I already have 675, and I've just started my Kubernetes cluster. I have not deployed anything yet. And if we do this watch command of Postgres that will keep executing this request over and over again, you can see that something is happening. Even though we are not even using our Kubernetes cluster, something is happening. Kubernetes consistently, endlessly interacts with the store. If you want to take a look at the structure of this database, let's do it together. We can do d plus Kine. So we have ID of the event. We have the name for this event. And some other information, like when created, deleted, some of the versioning, some Kubernetes-related matter. What we can do as well, let's just type the names of those events, what exactly is being written by Kubernetes into Postgres from Kine. Let's order by ID descending, and I want to show the last 5 events. Select ID name from select, And then we again can repeat watch, and you will see that, yes, something happens like leases, like lease-related information is being written right now. So the cluster, but at least it's good that Kubernetes managed to connect to Postgres using Kine, and it took us how much time? Like just seconds, right? It's already running. Now let's double check that everything works as expected. Let me do kubectl get nodes. So it's ready. That's my VM, control plane, master. Everything is good in a good state. So this is vanilla Postgres. Generally, we have Kubernetes, we have Kine. Kine is being developed by another group of people, and we have databases that are developed by different community members. Now, let's talk about distributed Postgres, because it's cool that we can use Kine to connect to vanilla Postgres or vanilla MySQL. But those two databases, they're designed to work within a single server environment. They're not scalable as the TCD. They're not as highly available as TCD. If you want to make Postgres scalable or highly available, you need to use additional extensions and solutions from the Postgres ecosystem. One of the solutions is YugabyteDB. YugabyteDB is a distributed Postgres database. So generally, it's a shared nothing database that works across multiple servers, regions, zones, etc. And it consists of the storage layer, query layer, and the storage layer. The query layer is Postgres. It's basically a fork of Postgres. And the storage layer is like they took the storage layer of Postgres, B-trees, etc., removed it, and used their own LSM3-based implementation. As long as I don't have any slides, I just can go to the website of the company, and here is, let's say that you have a 3-node cluster, it runs. This is our application, this is Kubernetes that uses Kine and uses Yugabyte as a storage layer. And you just write the data, all the tables, the Kine table will be sharded across multiple nodes. The traffic also can be load balanced. If any of these nodes goes down, that's not a problem because you have the other 2 nodes and they will be able to serve the request from Kubernetes. Same as the TCD, YugabyteDB also uses the Raft consensus protocol to ensure the consistency even during outages and split brain situations with your network. Now, let's get to the cluster and to the demo. What I will do now, I will let me destroy and stop my K3s deployment, because I will restart my Kubernetes cluster on YugabyteDB, and now you will see that we no longer have any new events coming to Postgres, because I killed my Kubernetes deployment. And we can exit from the connection to the database. Now, Yugabyte. What I did with Yugabyte, the reason why I have these 3 virtual machines, I decided to deploy a multi-region YugabyteDB cluster, because let's say that I want not just to scale, but I also want to tolerate region-level outages. If any of these regions goes down, or there is some incident, then still my storage, my distributed database will be able to operate normally. And also if I deploy Kubernetes across several regions, then the control plane and everything will be up and running as well. So same as Postgres, YugabyteDB is also open source, and I decided to deploy, to download the latest version and deploy it on my machine. So it's located here. This is my first VM. The cluster is already running because I wanted to save the time, but I will show you the status from the command line, and then I will show you the UI. So YugabyteDB comes with this YugabyteD tool, and it can show me the status of my cluster. So it said that the cluster is running. I have the replication factor is 3. It means that there will be 3 copies of every record for every data in this database. And I have 3 nodes, and there is a node in every region, which means that every node will keep a copy of every record, of every state that is written by Kubernetes into the table. So this is the address, and let's do this. It's running on this local private IP address. Let's do this. Let's use PSQL. Where is my connection to Postgres? What I need to replace, I'm connecting to Yugabyte. That's the host number. The port number is different, and then the user is Yugabyte. As long as YugabyteDB is built on Postgres, it's runtime and feature compatible. I can reuse PSQL and other tools. So we don't have any relations, and now let's fix it. What we are going to do next, we are going to use exactly the same command. We are downloading this K3s script with the latest release, and we are going to start it. We are going to use the following endpoint. Again, when the Kubernetes starts, it will see that we want to use Postgres, so that Kine will be using the implementation for Postgres, but in fact, it's not going to be vanilla Postgres, because this time Kine is going to be connected to YugabyteDB, even though it doesn't know that it connects to the YugabyteDB. it will be using the Postgres implementation. All right, so let's start it. The startup of the cluster will take a bit longer time because it runs across multiple regions. And there is probably, it might be possible to introduce some of the implementations related to distributed databases. But still, you can see that right now we also have in YugabyteDB this table. This is the sequence. This is actually the sequence that generates those unique IDs for every event that is written into the database. Let's check the count for the events from Kine. Okay, something is happening. We have the events coming. At least no any failures. I'm glad to see it. Let's do the same. Let's see the last 5 events. From Kine, order by ID descending, the latest first, and let's print the 5 latest on the screen. And then we run the watch command of Postgres, PSQL, to see the events. So generally, it looks like the cluster is up and running. It's good. And what I said about Yugabyte, let me quickly go here. Yeah, Yugabyte also has a built-in monitoring panel. If I go to, let me use this external IP address of my cluster, of one of the VMs. It's on this port number. So this is the UI. You can see that this is my cluster. I have these 3 nodes. One node is in Oregon, another one is in Las Vegas, and the last one is in Salt Lake City. They are running. If you go to the databases, you will see this Yugabyte. You can see this Kine table. Also, you can see that Kine created several indexes. Let me show you to expedite the access. Some of those indexes, to be fair, needs to be reviewed because they are irrelevant for a distributed database, and you need to create something else. But that's out of question for today. At least it works, and it works pretty well. Now, let me check if the cluster is operational. Yeah, everything is up and running. Let's do this. We have something that is working. We have some events in the database. Again, that was a quick process. It took me longer to deploy a distributed database cluster than to start Kubernetes on it. But now I downloaded a few basic Kubernetes examples that many of us, I guess, used in the past. Let me go to this sample folder. I just want to start a sample application on Kubernetes, and then I want to make sure that it works when Kubernetes is running on a distributed database. So we are using this kubectl apply command. We are going to deploy this emoji Voto example. And now let's take a look. While this example is being deployed, take a look at the database. You can see this is what's being stored. All this information that something is being deployed, emoji water, services, replica sets, etc., all this information is stored. Kubernetes API server pushes this information to Kine, and Kine pushes this information to distributed Postgres. And this is what's happening. Now, I don't see any errors, which is great. Now let's take a look at this deployment, what's inside. Scroll up. Yeah, so we have, you don't scroll well, glitching. Something is glitching. So we have some ports. Let me run it one more time. Get all, I don't know. My touchpad doesn't listen to me. Anyway, we have ports, we have services. What else? Let me do this, at least this service. Let me take its IP address and try to connect to it because it stands in front of a web app. I will use HTTP tool to pin the service. And we are getting back some nicely written HTML file with some JavaScript. So generally, everything works normally. Kubernetes runs on distributed Postgres that can scale across servers, regions, and zones, and that can tolerate various types of outages. And it's easy to accomplish, especially keep this in mind when you might want to use this solution. It's when you're really running large Kubernetes deployments, hundreds or thousands of nodes. I was involved in one of these projects. And when I was involved in that project, we did not have Kine. So we had to manually just use our own fork of Kubernetes just to replace Kine with another distributed database. But these days, there is Kine. It's a very well-maintained project, and it allows you to use Postgres, MySQL, or distributed Postgres for your needs if necessary. Now, as long as we have, 10 minutes? Let's try to do this. Let's see what happens if I bring some havoc. I haven't actually tried it with this demo, but as long as we have time. Let's suppose that there is some outage in this region. Let's shut down this virtual machine. Let's see what happens to the database, and let's see what happens to our Kubernetes cluster. We are not going to stop the database nicely. We are just going to kill this VM. I want to see some errors on the database. So here, nothing yet. It's still being stopped. Waiting. Stopping it. Yeah. Probably Google wants to shut down it now gradually, nicely. But we'll see. Let's check what's happening with Kubernetes. kubectl, get nodes. The database is responding. What's happening with Google? OK, VM is stopped. Let me go to the database. Yeah, the UI is glitching. I don't know why. But here you can see that the database is functioning perfectly well. Yeah, the nodes screen. Yeah, this node is clearly dead. I think this is the UI that was not updated. Let's do this actually hack. YugabyteDB has this function called select, because I'm connected to another node of YugabyteDB cluster. I killed one VM and it shut down one of the nodes. YugabyteDB has this built-in function called, I guess, YB servers. Right, so I have 2 nodes left, right, according to this function. And that's enough. 2 nodes is enough because the replication factor is set to 3. And YugabyteDB uses the rough consensus protocol. If the replication factor is set to 3, then we can lose up to 1 node. We lost 1 node, and that's OK. The database can keep accepting read and write requests. If I kill 1 more node, then the database will be operational, but it will stop accepting read and write requests because the data might be in a not consistent state. But as for the Kubernetes, it's fully operational. Let me call this service. It works. And hopefully, if I go to this screen, was it refreshed? No, the UI, something is glitching with this UI. But at least the database is up and running. Kubernetes is functioning. And we emulated a region-level outage. One of the database nodes went down, but we survived. So that's it, what I wanted to show you. It's supposed to be a simple and quick demo, and hopefully that was the case. So now, as I said, the reason why I decided not to create any slides for this demo and why I decided to do this hands-on is if you folks find this useful, if you think that would benefit your current or future project, then you know the pointers, you know already Kubernetes, you know relational databases such as Postgres, and the only one missing piece in this was Kine. If you want to use a relational database such as Postgres or YugabyteDB distributed Postgres for your Kubernetes deployments, you need to get Kine. Kine is very well maintained, it's stable, and it's blessed for production. So thanks for coming, and we have 5 minutes left if you have any questions. Okay, we've got a question.
Hello, can we hear you? Yep. Question, what consistency guarantees does this provide, and how have they been validated?
So from the consistency guarantees, YugabyteDB is a transactional database, same as Postgres. It supports all those essential isolation levels, such as read committed, repeatable read, serializable. And by using, and as long as we are talking about a distributed database, when you execute a transaction, when you need to, like each this update, right, it needs to be replicated across multiple regions. YugabyteDB uses the Raft consensus protocol, meaning that you start the transaction, and when you need to commit this transaction, you need to get a quorum at least of 2 nodes of your cluster with a replication factor of 3. So once 2 nodes come to an agreement, this update is considered completed and fully consistent, and your application gets back an acknowledgement and can continue its execution.
Thank you. Yeah. Quick follow-up. So point of clarification. So one thing etcd provides is something called strict linearizability, and it's a stronger consistency guarantee than Postgres's serializability. So if anyone's considering running this in production, I'd suggest you check those consistency guarantees. Thanks.
Yeah, from consistency guarantees, because by default, Postgres uses read committed. And read committed is good enough for most of the workloads, but sometimes folks, especially if you move money or you have some kind of multi-step business applications, get to know different other isolation levels that are provided by Postgres, YugabyteDB, and other databases. This is a good point.
Yeah, if you'll allow a short follow-up, there's a fantastic bit of research from Carl Kingsbury, who does Jepsen testing of databases. Yeah. And suggest folks have a look into that when they're considering these kind of options. Yep, thanks.
Yeah, thanks a lot.
Hey, great talk. On a similar line, so are there any drawbacks for using Postgres versus etcd? Was my question. Like, why would we not use Postgres even for less than 100 nodes, for example?
Because I didn't hear a question well.
So why not use Postgres or relational database for even less than 100 nodes? I know you mentioned scale was one of the criteria we would use.
So the reason why I showed Yugabyte, because in the Postgres ecosystem, it's easy to scale reads. When, let's say, many of us use probably Amazon RDS or Google SQL or some other managed services of Postgres, or you can just start your Postgres. Like generally, like the general approach when we talk about Postgres scalability is one primary server that handles both reads and writes, and then you have replicas. And the replicas help you to offload the read traffic, and also those replicas just receive changes from the primary and can be promoted to the primary if necessary. The reason why I showed YugabyteDB is because for the use cases when you want to scale both reads and writes, and when you just want the database itself just to easily handle all those failures. Because in the Postgres ecosystem, when you use Amazon RDS as an example, that comes, let's say, with one primary, let's say 2 replicas, or Amazon Aurora, then the service itself handles all those failures, and it can take, I don't know how many minutes or more to promote a replica to a primary. It depends on your requirements. In case of distributed databases such as YugabyteDB, it happens much, much faster. It's usually just in tens of seconds, like 5–10 seconds, depends on the network latency, etc. But generally, this one is for those who truly wants to have high availability out of the box, just within the database with the recovery time objective. It's like recovery time objective is how fast your database can how fast your database can handle an outage, and for Yugabyte is around, let's say, 10 seconds. And if you want to scale reads and writes, if, let's say, you just need to scale reads only, and you are okay to wait, let's say, a minute or so while your replica is promoted to the primary, it's fine to use, let's say, Postgres in a configuration with replicas. That's totally fine. That's it, yeah. So yeah, unfortunately, we ran out of time. Let me take one last question, and then, folks, if you have other questions, I will be happy to chat to you privately, right? Last question.
So I'm not as familiar with PostgreSQL, but is there an idea of partitions that you can actually take different resources and say pods are going to be one database while nodes are in different ones? So if you get different resources scaling up at different rates, you can actually kind of handle that dynamically rather than reconfiguring the API server to point to different things?
That's one I don't know. So my kind of expertise primarily lies in the database part. So like we can discuss, let's say, if you kind of understand what needs to be done at the layer above, right? Then we can sit down and discuss, all right, how this can be supported by the database, because databases like this one, YugabyteDB, internally it uses partitioning, like sharding to shard your table across the cluster. Postgres has the concept of partitioning. It's when you have your primary table, and then you can split the table by a partitioning key into child tables. So generally, if you have some concept in mind that you try just to project how to project this concept of the database, this is what I will be able to discuss. If it's unrelated to that, then unfortunately, I'm not the best guy to ask.
Thank you.
All right. All right, thanks a lot for your time. Thanks a lot for coming. And if you have any other questions, I'm happy to chat here.